So my question wants us to calculate the pOH of a solution that contains 3.9 times 10 to the negative fourth molarity of H3O plus at 25 degrees Celsius. So first are the equations. And our first equation is pH equals negative log of H3O plus in brackets, and pH plus pOH equals negative 14. We will rearrange the second equation. We will rearrange the second equation so that the pOH is on the other side of the equal sign. So it will read pOH equals 14 minus pH. So we'll start with step 1. We're going to write out 3.9 times 10 to the negative fourth H3O plus, and then we're going to find the pH, which we discussed on the last slide, which negative log of the equation given. So it's going to be negative log of 3.9 times 10 to the negative fourth. And then we're going to go ahead and separate the equation. So we will move the negative sign outside of the brackets and just have the logs on the inside of the brackets. So once we put it in our calculator, we get that log of 3.9 is 0.59 and log of 10 to the negative fourth is just negative 4. And then we're going to set that equal to the pH, and we're going to remove that, keep that negative sign on the outside. And since we're adding a negative, we don't really need to put the addition sign and the negative sign. So we're just going to remove that addition sign and put a minus sign for that 4. So it reads pH equals negative bracket 0.59 minus 4 bracket. And then we do that out and we get the pH equals negative bracket of negative 3.41, and then we close the bracket. And that's just going to give us a positive number because we have two negatives. So that's going to give us a pH of 3.41. And since we now have the pH, we're going to use the second equation from the first slide. And we're going to set that pOH equal to 14 minus the pH, which is just going to be 14 minus 3.41, which equals 10.59. So our pOH of 3.9 times 10 to the negative fourth molarity of H3O plus at 25 degrees Celsius equals 10.59.